Well, welcome back. We're taking a look at lesson 5.3 here, solving polynomial equations. We're going to take a look at a couple different ways to solve equations involving some different exponents. We got a cubic here. We got 1 to the 4th degree here. So just a couple different ways to solve these things. So just a real quick review, that if x minus a, and again, this can be x minus 3, x minus 4, x plus 8, if that's a factor of the polynomial, then that means that polynomial has a value of 0 when x equals a. And then that's also if a is a real number where the x-intercept is of that thing. We're going to use that just a little bit later. Now, today we're also going to look at that there are real and there are also imaginary solutions to some of these equations, and we're going to get into that just a little bit. So let's go ahead and start and look at this. All right. So to solve a polynomial equation, again, we want to get one side equal to 0. So I'm going to take away 3x. And that gives me 2x cubed minus 5x squared minus 3x equals 0. And I want to look to see if I can factor this thing. I don't see any common factors between the numbers, but I do see that I can factor out an x. So let me take that out. And that gets it to 2x squared minus 5x minus 3. And that makes me feel a little bit better because now I know what I have in here is a quadratic. So I can solve this by using the quadratic formula. There's my a, there's my b, there's my c. I'm going to see if I can factor it real quickly. And now again, with that 2 in front, we talked about this earlier here. So 2 times negative 3 is negative 6. And are there any factors of negative 6 that add up to negative 5? Yeah, they are, negative 6 and positive 1. So this thing can be factored. So I'm going to go ahead and see if I can factor that. So that'd be x and 2x squared. Now I'm uncombining the negative 5x using these two numbers that I just found there. So that'd be minus 6x plus 1x minus 3. And now I can group these, and I'm going to group them with some brackets here just because I've already got a set of parentheses and I don't want to make myself confused. So if we look inside this first set of groupings here, I can factor out a 2x, and that would leave x minus 3. And here I really can't factor out anything. So I can factor out a 1, I guess, all right, which would still leave me x minus 3. Now again, that whole thing is still in parentheses, and we still have that x from the beginning that we factored out way at the beginning here. But now just looking at what I've got in here, I've got a common factor of x minus 3. And then I've also got 2x plus 1. And I've still got that x at the beginning. And all the way through here, I guess I should say, should have been saying, hey, this equals 0 all the way through, because all we were doing is factoring the left-hand side. And now we're almost done. I'm going to use that zero product property. I'm multiplying a bunch of things and getting 0. So that means one of those things has to be 0. So either x is 0, x minus 3 is 0. Slide my paper up here, give me just a little more room. Or 2x plus 1 is 0. So I've got one of my solutions. Solving that one-step equation gives me a second solution. And then I've got a two-step equation here. Divide by 2, divide by 2. There's my third solution. That should be negative 1/2 there, not negative 1/3. Okay. So again, all of those are solutions to this equation. Matter of fact, they're solutions to the original equations. If I replace x with any one of these values, it would make that equation true. But again, the key thing was getting it equal to 0, noticing that I could factor it, getting it in its factored form, and then using that zero product property. So if we look at the one on the right here, Again, I want to get it equal to 0. And then I'm going to write it in standard form, which means from highest power to lowest power. So I'm going to rewrite this as 3x to the fourth minus 6x cubed plus 12x squared. And it still equals 0 now. 6x cubed minus 6x cubed is 0. And again, I want to look to see if I can factor it. And here, I can take out a 3. And I can also take out an x squared. X to the fourth, x cubed, x squared. All of those have an x squared in common. So I look at what's left. 3x squared times what would give me 3x to the fourth? That's x squared. 3x squared times what would give me minus 6x cubed? That would be minus 2x. And then 3x squared times what would give me 12x squared? That would be a 4. So now I got good news and I got bad news. The good news is, if we look to factor this, that's just got a 1 in front, so we don't need to do this step we did over here. I can just find the factors of 4 that add up to negative 2. And here's the bad news, there aren't any. All right, so that means this thing is not factorable. So what we're going to have to do, we'll deal with this in a little bit. All right, so hold on to that. We're just going to focus on this. All right, so to solve this equation, I'm going to have to go to the quadratic formula. All right, so I know A is 1, I know B is negative 2, and I know C is 4. All right, so let's go through the quadratic equation. So it's the opposite of B. The opposite of negative 2 is 2, plus or minus the square root of B squared, so that's negative 2 squared, minus 4 times A times C. And the whole thing is divided by 2 times A. So now I got to work underneath here, and I'm also going to simplify that. So I get 2 plus or minus. Negative 2 squared is 4, minus 4 times 1 times 4 is 16. And that's all over 2 times 1 is 2. And now, still working underneath the square root, 4 minus 16, I get 2 plus or minus the square root of negative 12 over 2. And now I'd like to simplify this. So I'm going to rewrite this as 2 plus or minus. So the first thing I'm going to do is pull out that I. All right, remember when we talk about the square root of a negative, we know we're talking imaginary numbers. So I can pull out that square root of negative 1. And then 12 is 4 times 3, trying to find factors of 12 that are perfect squares, and 4 kind of fits that bill there. And so now we can write this as 2 plus or minus. The square root of 4 is 2i, radical 3 over 2. And I'd be perfectly okay with this answer. If you want to catch, hey, wait a minute, all those are divisible by 2, you can write 1 plus or minus I radical 3 over 1, which you really don't need. So that's 2 of the solutions, 1 plus I radical 3. And the other solution is 1 minus radical 3, or I radical 3. Now, the other solution, remember I said we're going to deal with this here in a little bit, because the other solution is, hey, when is this going to equal 0? Well, when will 3x squared equal 0? So I'm going to solve that here. So when will 3x squared equal 0? I divide by 3. When is x squared going to equal 0? I actually get a third solution there, really a third and a fourth solution, because remember we do plus or minus with that, but there's no such thing as a negative 0. This would be one of those, has a multiplicity of 2 there, but my 3 solutions are 0 and 1 plus I times the square root of 3 and 1 minus I times the square root of 3. So sometimes you're going to start factoring, but if you get a quadratic that can't be factored, you might have to go to the quadratic formula, and notice we are talking about some imaginary solutions here. So any of these values, if I put them in the original equation, is going to make this original equation true. All right, so let's look at the backside. So when we start talking about different techniques, there's a lot of different factoring techniques that we can look at. The first one we saw in there is factoring out the greatest common factor. That would be something like we just saw it. I'm just gonna 15x squared minus 20x cubed plus 35x squared. Like here, I know I can 15, 20, 35. I can take out a 5x squared, and that would leave 3x squared minus 4x plus 7. So one of the kinds of factorings you're going to look for, and this is really always the first one you should try to look for, is factoring out that GCF. Next one you should look for is quadratic trinomials. All right, so something like 6x squared plus 11x minus 10. Hey, can I factor that? Well, 6 times negative 10 is negative 60. And factors of negative 60 that add up to 11 would be 15 and negative 4. And now you can go from there. Perfect square trinomials, I'm not going to spend a whole lot of time on because, to be honest, you'll catch those up here. You can just factor those like normal, and it'll just turn out that the two factors you get will be identical. You'll get an x plus 4 and an x plus 4, or 2x minus 3 and 2x minus 3. So I'm not going to worry too much about perfect square trinomials. Next one is the difference of two squares. Okay, this is where I have if I've got x squared minus 16. I know I can factor that as x plus 4 and x minus 4. So get to know that difference of two squares. Factoring by grouping, we're not going to talk a whole lot about. That kind of comes into play up here, but that's nothing I'm going to concern ourselves with right now. But this one, the sum or difference of cubes, I do want to talk about that. So the sum of cubes would be if I have something like this, a plus b cubed. This can actually be factored as a plus b and a squared minus ab plus b squared. Or if I've got the difference of two cubes, we've got difference of two squares. If I've got the difference of two cubes, like a cubed minus b cubed, that can actually be factored as a minus b and then a squared plus ab plus b squared. So we'll look at this one. We'll look at one of these here in just a little bit, actually. But these might be a little bit new to you, so we might need to review those. You might need to review those a little bit. But these are some of the different factoring techniques that you might be asked to use here. So as we look at solving equations by factoring, first step is always the same. We want to get it equal to 0. And this is exactly what I was talking about. This is a difference of two cubes. This is x times x times x, and this is 1 times 1 times 1. So I'm actually going to factor this thing exactly like this. So I'm going to factor it as x minus 1 times x squared plus 1x plus 1. So a minus b, x minus 1, and then a squared plus ab plus b squared. So that came from right up here. And then we can use the zero product property. I know x minus 1 has to be 0, or x squared plus 1x plus 1 has to be 0. So here I get one of my solutions, and obviously I didn't give myself enough room here to solve this thing. But one of my solutions here is x equals 1. The other solution is going to come from here. So factors, if I look at trying to factor this thing, factors of 1 that add up to 1, there aren't any. Okay, which means unfortunately for this one we'd have to go to the quadratic formula. All right, and so I'm gonna leave that to you to do. But I will give you the answer. If you do the quadratic formula here, A is 1, B is 1, and C is 1, the solution actually turns out to be -1 plus or minus I radical 3 over 2. So solving these things by factoring specifically this one that is a difference of 2 cubes. If we look at this one, x to the 4th equals 16. Again, I get it equal to 0, so I subtract 16 from both sides, and I'm going to write this up here just to give me a little bit more room. I get x to the 4th minus 16 equals 0. Now, this one, you might not recognize it right away, but this one is actually a difference of 2 squares. This is a perfect square, x squared times x squared, and this is a perfect square, 4 times 4. So I can actually factor this as a difference of 2 squares. X squared minus 4 and x squared plus 4 equals 0. And now I look at this again, hey, wait a minute, I've got another difference of 2 squares. So this thing I can factor even more as x plus 2, x minus 2, and x squared plus 4. I can't do anything with that because I notice I don't see a sum of 2 squares up here. This is a sum of 2 perfect squares. I see a sum of 2 cubes, but I don't see a sum of 2 squares. So this thing can't be factored. And I just want to know, when are these going to be 0? When is x plus 2 going to be 0? When is x minus 2 going to be 0? When is x squared plus 4 going to be 0? The first two are pretty self-explanatory. They're one-step equations. This one, now I can actually use the square root here. I can subtract 4 and subtract 4. I get x squared equals -4. I take the square root of both sides, and x equals plus or minus 2i. So again, I get 4 answers here. All right, -2, +2, +2i, and -2i. And then finally, just another one to solve here by factoring. Again, I'm going to get it equal to 0. And the one that has the highest power, I like to leave with a positive coefficient. So rather than subtracting x cubed, I'm going to subtract 8x and add 2x squared. And I'm going to do that to both sides. So that's going to give me x cubed. And writing it in standard form, I get plus 2x squared minus 8x. And it still equals 0 here. Now I look to see if I can factor it. Well, I can factor out an x, and that leaves me x squared plus 2x minus 8, and it still equals 0. And now, can I factor this? I hope so. Factors of -8 that add up to 2, yeah, I can. So that'll be x plus 4 and x minus 2. I've still got that x there. Again, +4 and -2. Multiply together to give me -8, but add together to give me 2. So that means I didn't have to go through the quadratic formula. And now I'm multiplying 3 things and getting 0. One of them has to be 0. So this would be x equals 0, x plus 4 equals 0, which would give me x equals -4, and x minus 2 equals 0, which would give me x equals 2. So again, three solutions, 3 different solutions to that equation. So lots of different factoring going on here. All right, greatest common factor, the trinomials we've seen before, difference of 2 cubes, and a difference of 2 squares. But just a lot of different things to have in your toolbox as you look at these. Now we can also solve these things by graphing. All right, so if you grab your graphing calculator, there's actually a couple different ways to do this. Your book goes through a couple different ways. I prefer getting it equal to 0 and then finding the roots. If you're interested in method 1, take a look at method 1 on page 299. I'm not a big fan of it, but you can take a look at that and see if that makes sense to you. But what I'm going to do is get this thing equal to 0, and I'm going to use the roots function on my calculator. So I've got x cubed minus 4x squared plus x plus 5. And I want to know when that equals 0. Again, I just put it in standard form here. So if we grab our calculator, hit y equals, all right, clear off whatever happens to be there. So I'm just going to type this in, x raised to the third. Make sure I are out of that, minus, make sure you use your minus, whoops, make sure you use your minus button, not your negative button. So minus 4x squared plus x plus 5. And again, I'm going to just go to zoom 6, zoom standard here, see what this looks like. Oh, it's pretty. All right, I love this. All right, so I can see 3 different solutions because we want to know, when does this thing equal 0? Well, it equals 0 at the x-intercepts. So really, I want to find these 3 x-intercepts. So I got to do this 3 times. So I'm going to use that calculate menu. So second trace, and I want to find the 0. And again, so I go left bound. So I'm going to find this one first. All right, so I put my cursor to the left-hand side of that, and then to the right-hand side of it. Make sure I don't get over here by this one. So one of mine is at, and it looks like it's not going to come out pretty, so let's go a couple places past the decimal. So about negative 91 hundredths. All right, so one is at about negative 91 hundredths, which means, this, if we could have got this down to something factorable, we wouldn't have been able to. We would have had to do the quadratic formula. Let's find this one. All right, so I'm going to do it again. Second trace, and I want to hit number 2. All right, now I'm going after this one. All right, so I just want to get on the left-hand side of that root, and then I want to get on the right-hand side of it. Make sure I'm not getting over here on the right-hand side of that one. About 1 71 hundredths. Okay. And then finally, I want to find this one here. So again, I do it again. Second trace, number 2 for my 0. I want to do a left bound, get on the other side of it, do a right bound, and I get about 3 and, let's see, that 8 would round that up, so about 3 20 hundredths. All right, so x's are approximately, since I had to do some rounding here, 3 20 hundredths. Okay, so those 3 x's, not exactly, but these 3 x's would come pretty close to making this equation true. All right, don't know why I gave you the graph there. I guess you could kind of trace the graph of this thing. All right, and we're trying to find those 3 roots there if you want to just have a picture there to tell you what we did. All right, so take a look at this one. X cubed plus x squared equals x minus 1. Again, if you want to hit the pause button, feel free. Give this one a try, but we're going to do it together here in just a little bit. All right, so let's see here. Hopefully you got a solution here. Let's see if I can match it. So I subtract x and add 1. I get x cubed plus x squared minus x plus 1. And I want to know when that thing's going to equal 0. So I go to my y equals and clear out the one we just did. And I'm going to do x cubed plus x squared. Whoops. I think I did that before. Make sure I hit delete, not clear. All right, so I want that to be a cubed. All right, x cubed, and then I got an arrow out of that. All right. Plus x squared minus x plus 1. And I'm just going to hit zoom 6. Okay. Ooh. Now notice here, all right, this one only has one real solution, all right? Now, since it is a cubic, we were expecting 3, but the others must have been imaginary. But using the graphing calculator, we can only find the real solution. So all I have to find is that solution there. So second trace, I want to find the 0, so I hit number 2. I move it to the left of that x-intercept. I move it to the right of the x-intercept, and I'm getting about -1 84 hundredths here. So approximately -1 and 8400. Hopefully you got that answer as well. So -1 and 8400 is about right there. So it looks like this thing comes up here and then does one of these jogs, and there we go. Okay, so that's what we're looking for. All right. All right, so 5.3, all about solving equations. Some of them you're going to use algebra by factoring and doing different factoring. Some of them you're going to do using your graphing calculator. All right, so give this homework a try. I'll post the answers here, but again, don't hesitate to contact me with questions or ones you want me to go through with a little bit more detail. All right, take care, guys.